close the door. So the sound doesn't come out. All right, I'm here. How is everyone doing? If this is laggy because the speed is kind of slow, then you guys have to down res to 720. First of all, let me check if we have sound. Do we have sound? Do we have sound? Do we 144p? It seems okay-ish. So I think it's going all over the place. That's the bad thing. And I didn't set the maximum rate to be like something like 700 or whatever. So it's gonna try to push out at 1080, which is like the max resolution, but it might not do it. Or it might do it only like at times, and then at times it won't. So just if you down res and like, if you like go click on the bottom of your like little screen here, and then you put your setting, right? You can go like, see, quality auto is 1080 for me, so set it up for 720. It should force it down to 720. Should have a better I should have a better experience here. So how is everyone doing today here on YouTube? I'm finally back on YouTube. I've been gone 3 months, and that's why you guys have to follow me down over there at Twitch and on you know, Facebook groups, like all that nonsense, right? Because I couldn't be here. They totally slapped my wrist, and they took my ability to come here and do a live stream, you know, for 3 months. So there's 108 of you guys. That's crazy. Let me just see the thing. Let me just check the thing here. Did I do this or not? Yeah, okay, so that's on. All right. I even forgot how to live stream on YouTube. That's how long it's been. Not that I ever got it down, right? I mean, it was always a big mess. I didn't know how to do it. Oh my God, you guys, your comments are going so quick. YouTube Live. Where are you guys? Okay, Australia, I see here. IE, Chris Thomas. Inland Empire? Oh, those are my neighbors. Puerto Rico, Angelo, it's here. Sunny Monday morning. Oh, so Island Times, how's it going? You're from that little island off of Australia. Please add a subpage to your videos. I don't know what you mean with that, Janus. Please elaborate. We'd love to see your bourbon collection. Oh, actually, that's not bourbon. That's mostly tequila. I used to collect tequila, and then I don't know what happened. So I used to have like this custom thing that I used to put them there, and then I had to move out of there, and now I built that thing. So I kind of took it. Oh my God! From Turkey, Istanbul, Texas, New Zealand, Oklahoma. Wow, there's a lot of people. Scotland, 122 of you guys. Yeah, there's YouTube does a better job at letting you guys know about these guys. You know, let me set this thing to. Oh, do you guys get to see that? So I just set my. See how it's okay, let's see if that, yeah, that shouldn't pass it on. Let's see, this is the delay, and I'm trying to see myself. In the screen over here, it looks all blue. Oh yeah, perfect. See, now I'm in focus. All right. Okay, what are you guys talking? Saludos de Puerto Rico, says Leonel Perez. A lot of Puerto Ricans people here today. How is Puerto Rico doing? No more blackouts. Tennessee, Florida, Portugal, Miami, Czech Republic. Wow, so yeah, everybody's here. Phoenix, Arizona. That is pretty good. That is good. Look at that. 145. Yeah, it's nice to be back, guys. Definitely Twitch was fun trying to do that, but there was a lot of, you know, things to figure out, and you know, it's just, you know, there's not the people, you guys are not getting like notified over there, right? And even if I come and make a video here, I was risking getting another strike for trying to send you guys over there because it's against the terms of service. It's a big giant ban. Good quality here. Turn off your ceiling fan might help. Oh, that's right. That's right, because that does eat a lot of bandwidth. What if, oh man, so what if I just go like this? Oh man, then like my face. Then you guys get to see more of my face. We don't want that. Yeah, it's hot. By the way, guys, been hot. Last Friday was definitely the hottest day. It was like 115 here in California. It was crazy. I mean, even though the Death Valley's just down the road here, right? And that's, you know, regularly 115 or whatever. There we go. So that's gonna help. Hopefully that doesn't have to encode that fan there, and it should be good. Wow, 171 watching now. Wow, welcome everyone. Welcome to my channel this Sunday afternoon. At least for me, Sunday afternoon live chat. Can post links on YouTube chat? Oh, yeah, so some people can. I would have to like make you like I think I'd have to like make you let's see, how do you do this? Repost. Okay, I just added you as a moderator, Island, and so now you can post links there if you want to. Yeah, it just keeps that so that people don't bombard you with like spam and stuff like that, you know? Oh, David Jensen, thank you for the super chat there. Yeah. So what do you guys think about these this system here that I'm making? I'm trying to get it down so that we can build large battery packs like quickly. We don't have to do like a bunch of these, you know. Who wants to sit there? I mean, that's a good thing, don't get me wrong. It's a lot better to like sit here and learn how to do it, right? But then after you make like a few modules and you get it, you're like, all right, now I gotta sit there and you know, do all that whole thing. Like it just kind of gets old, right? And if you're building a super large pack like me, I'm a crazy, right? I'm always doing this little things, and I'm, you know, I don't have a giant battery pack like some of you guys, but I have a bunch of little ones, you know. It's that, like, I'm always messing around with batteries, always doing it. But yeah, I have a purpose of doing it. A lot of you guys, you just want to build this stuff and put it on the wall, start using it. You don't want to, like, you know, be doing this for ages. So that's why, you know, this system here was like perfect, because one, it allows you to just pop the batteries in there and then stack them, and, you know, like, it's still some assembly required, but it's not no crazy, right? Because all this is standard soldering, so that means I can pay some third party in China to do that for us. So we can order the boards completely populated. Now you just have to screw them together, you know, put the batteries on there and slide them. I mean, like, you still have to, like, you know, test the batteries, make sure they're all okay, they're all, like, you know, similar capacities and stuff like that, and then you put them together. It's just, this eliminates a lot of the work, and that's what I'm trying to do. And since, you know, a lot of you guys are doing the big, large battery packs, then that's where this comes into play. Some people have suggested that maybe I can find a way to put the battery holders on both sides, but I don't see how I could do that. Like, there's just no way. Once there's two of those in here to get the soldering iron there, like, there's not enough room. You'd melt like the side of these guys trying to get in there, get in solder and get the heat on both sides. It would be a nightmare. You know, it would be hard, and it would, you know, I don't think that would be possible. So I thought about it. I thought about offsetting it, but then you still don't have access from the backside. Like, the only way to solder these is from the backside, really. So unfortunately, that doesn't work. The only way you can put batteries on both sides is if you do this, right? And I hot glued these in here, and then I put the thing, and it was a lot of work, a lot of time, but what I didn't realize is that it was a board. I only have 4 of these boards right now, right? So I had to, like, desolder the old thing holder there, and then I had to put the thing, and it makes it 10 times harder. So if it's a brand new board, you should be able to stick that little, you know, cable that you're gonna do, and then, you know, either weld them, spot weld them, or solder them. It'll be easy. So maybe it's not as slow as I make it seem, right? And it's just I have so little boards to play with. So I order the first batch, and it's 100 boards, and they shipped on Friday. I think they're gonna be here like Tuesday or something this week. So I should be able to have a bunch of these to test. So I can start building something like this, right, and time myself, you know, just go like normal, and then build the other ones and see like just how much time really it would save, you know. And then I can like pretend that I got them like pre-populated, and then like, you know, pop in the batteries and then put them together and time that and see like if it actually makes sense. You know, if I'm building a rapid build system, then, you know, it's gotta be faster than doing it the traditional way. I could also, you know, put another try the traditional way and then test myself and sort of like that. And then hopefully a few of you guys will want to get some of these. I'll put a button so you guys can like order a couple of them or whatever, and then you guys can do the test if you guys have already built, and then we can have little videos back and forth. And then Justin today sent me a link to the video. Oh, maybe we should watch it all together. Oh, that's right. Let me load it up. So he was testing the traces. You know, this has got trace fuses, and a lot of you guys don't believe in trace fuses, right? They're like, why are you using proper fuses? Why are you using cable, you know, like leg resistors instead of proper fuse? And I'm like, I consider any wire, you know, every like fuse wire, they're saying, right? And I'm like, all wire is fuse wire. If you give it enough current, it'll pop, you know what I mean? Like, yeah, of course, like it's a little bit less reliable or whatever, but you know, there's a threshold, and I believe the threshold is below, at least for me. This is good enough, right? Because it's coming out of like a resistor or whatever. If you want to use fuse wire, go for it. Like, you can use it, you can do it like this also. I'm a hack. I'm trying to look at you guys, the hack. So let me load up that other video, and then we can watch it together. I'm frozen in my screen. Hopefully I'm not frozen for you guys. Is it happening? Man, and it's gonna be hard to read all your comments because they're going so fast. If I have trouble in over there at Twitch, where there's like only like 80 of you guys that show up over there, it's gonna be crazy today. Okay, so he sent me. Okay, here's Justin. Come on, load up. Come on, computer. This computer is kind of slow. Hopefully, it's not going to. Made a video about the BM. Okay, here we go. That's the one. Oh man, this computer is struggling right now. Hopefully it's not. Okay, so then I have to shut down mail, because that's another program that is just gonna freeze our thing. Quit mail. Hard lag, yeah. So I was just trying to open my email to check the thing, right? Okay, let me load it up over here. Boom. Okay, so I have to remember the audio. I've done this a couple times. I don't know how many of them have been successful. I think so. I have to turn one volume off or whatever so that it doesn't like do twice. Okay, oh my god, yeah, this computer is struggling right now, and you guys are probably lagging big time. Okay, come on, computer. Okay, there we go. So it loaded up. Okay, let me stop it, and then let me load up over there on OBS. Yeah, watch video, right? No, play video. And then I'll go to browser. If you guys, any of you guys have done this before, There we go. Look at that. I just loaded it up. Wait, is that crazy? Oh, no. How do you... Oh, there we go. There we go. Okay. I just have to set up the size so that we're not only watching like one tiny little bit of the video. There we go. Set it up a tiny bit smaller. Whatever. Let's okay, the audio. Camera audio? Well, you know what? We probably don't have to worry about the audio because it doesn't have any audio. He doesn't talk. It's just like fan noises and stuff like that. All right. Let me check if you guys are still with me. Still with me? 10 frames per minute? Not per minute, come on. How is everybody? Am I still live? 189 of you guys watching. Wow. Let's play that video. CPU need more power. Yes, it does. This is a top of the line MacBook, by the way. And it can't handle like a simple stream. What's up with that, Apple? What's up with that? Come on. Okay, here we go. Let's play the video. I'll transition it. Right? So you guys are not seeing me anymore. Camera audio and then browser audio. We'll turn this browser audio off just so that we don't do the thing. And you guys can still hear me, right? Can you guys still hear me? You're still here. That explains it. Audio is great. That's all that matters. All right. Oh, wait a minute. I'm playing the play on the wrong side of the thing. Okay. Here we go. All right. So I'm not playing the audio because, well, there's not that great audio in it anyways. So when he's testing, I think the traces, right? That's what he's doing here, like testing, measured. Oh, how much was that? Should we pause the video there to see what he said? 2 methods. Okay, so let's read that. There are 2 methods of estimating fusing current on a PCB trace. One, Priest's equation, and then he gives out some mathematical formula there that I have no business trying to read because I don't know math, right? And then number 2, but some of you guys might understand that. So I equals fusing current in amps, and A equals cross-sectional area. Oh, actually, it's kind of simple, right? Okay. Under dunk equation. Oh my God, look at that name. And then he's got another equation there. I stands for fusing current in amps. A equals cross-sectional area, just like the one before. But then T on the bottom is equals for time it takes to melt in seconds. The calculated result. And piece is 1 second at 3.2 amp, and then calculate result on their dunk is 3 seconds. Okay, there we go. So he has the board there, and hopefully you're like, whose slide is that? That, oh, by the way, that is Justin, the guy that did the layout on the PCB. Okay, let's look at the thing. That's my work, by the way. What is that? This one I haven't made the video public yet. Leaf Rex, is that you? Is that you, Justin? So there we go. Oh my God, look at that. 390. Well, that got to like 300 degrees Fahrenheit. Don't ask me what's that in C, because that's like, I don't know, 150 C or something, I don't know. And result transfused at 12 amps, 2.4 seconds, 3.75 times. Okay, so now part 2, fuse cooking test, leaving 10 amp. Okay, so that was it. So what, let's see. Blu-ray player do we have? Oh, sorry. Let me just answer that. I don't know. Sony? I think we have Sony. Send. Let's see if we can pull this back. So what do you, man? There. Thanks for watching. Fuse cooking test. A 10 amp load, leaving more or less. Come on. I was reading that, man. Fuse rates low enough not to melt, but high enough to potentially burn. FR-4. And I guess these are future tests. Test 2 DIY tech and repairs. Test reverse BMS connector with cells loaded, effectively shorting all 7 cells. So I kind of did that. I kind of did the short test, and with these cells, let me change the view here. So I kind of accidentally plugged them in the opposite way, right? And all of the contacts here, like all the leaf springs, they were just glowing red, like really quick, right? Because these could put out some power. And so I think those were cooking before the traces, so I didn't leave them there long enough for the traces to cook. So I think what's gonna happen if we do that test, I think what's gonna happen is that this stuff's gonna start melting. The plastic here is gonna start. So these are going to like glow red at 10 amps. Like 10 amps, do they glow red? Maybe not, but at 10 amps, I think if they last for a little bit more than, oh man, I don't know, 5 minutes. So they wouldn't last 5 minutes. I'm hoping that, yeah, the fuses will burn before the plastic starts melting. Like starts like, right, it starts pushing out because the leaf has tension and it starts giving out. So that's a test, right? I mean, it should be simple, but I don't know. Actually, I thought I knew it was gonna happen in my head, and it turns out I don't know. I think it's going to, yeah. Hopefully the fuses are gonna work. So that's a test that we gotta do. Okay, let's see. Let's try to read some of your messages here. That's if I'm still live. Am I? What does this thing say? Oh yeah. So I'm sustaining a bit rate of 2,000 kilobits per second. So again, if you're having trouble, if it's buffering, force your browser down to 720. I should have done that, but then by the time I realized what my speed was, I couldn't change it anymore. So I'd have to start a brand new, like it's a bunch of work. So I'm like, unfortunately, we have to do that. So you'd have to, let's see here. Come on, man. So now my live thing is not showing up. Okay. Okay, so I'm still live. Okay, so my viewer here. Okay, there we go. There we go. Use length of thin copper wire as a resistor to test 30 amp capable cell. The wire glowed red. Yes, 30 amps for a little bit, right? For a few seconds, and then after that, it probably just, you know, then it melted. How's the BMS going to work on the PCBs, Jay? It's got a connector here, right? And then you can connect it there, and then you can connect your any, whatever. You have your choice of BMS. You have a choice of BMS, and it's gonna have to be connected outside of this system, right? I don't have a way to install it there. I was thinking about ways to like put it in there, like slide it, sort of like a, you know, like a shield type, where like with these same connectors, you put it in there. I might still experiment a little bit with that, but you know, because these are large packs, then you know you're gonna have to, yeah, install your BMS and separate in another place, you know. And then run your high current through it if you're doing the cheap e-bike type BMS, or you're gonna have to run it through like contactors and shunts and stuff if you're doing the legit like you know, Batrium and stuff. So yeah, all these packs are going to be parallel. So you know, you're talking about 7 groups of cells, no matter how many of these you stack up. If you have 2 of them, it's 7 groups of cells. If you have 100 of these guys stacked up, it's 7 groups of cells. And so that's, you gotta get a BMS for 7, unless you're gonna be using 2 in series for those of you that want to do 14S and then do a 48 volt system. Then you could get like a big BMS and then split it into 2, and then you'll have this the modules that you build, you put them in series or whatever. Yeah, so this is like super configurable. You can put 3 of these in a row, and then you're talking about 7 times 3, 21 cells. If anybody, for any reason, would want to have that, or 100 volts. What, 48 now? It's yeah, 100 volts, right? Or close to 98 volts or whatever. 96 volts. Yeah, you could do that. You could pretty much do all kinds of things with these guys, except the only thing you can do is use one at a time and try to get more than 100 watts off of each board. At least now with this design, if you build it like this, then you can do about 400 watts before the board starts getting, hot and warm and whatever. I guess once we do, well, but those are those traces. The other traces are fine. They're just get warm. I think I did order some, where are these guys? So I ordered some, some fuses, right? These are, what are these? Are these the right size? Yeah, they're the right size. They're surface mount fuses, so they're tiny. They're kind of hard to put, but it's a tiny little thing. Like I said, I think the ultimate goal is to like provide every step, right? There's like a lot. You guys are all over the place. Some of you guys are super capable. You just want the files so you can get the boards yourself, right? And if you're like out of the US, it makes sense for you guys to just order them in China from your favorite PCB maker in China, and then you get the things and then you build them, so open source like that. I'm gonna make the files available to everyone. Also, there's gonna be like other people like me, where I'm like, I don't know what to do with the files. I just want to buy the PCBs, and so I also want to try and set that up, and if I can set that up in China too, where like they just sell them to you, and then they just ship to you straight, so I don't have to touch them, then that's great. You populate it, you do the thing, you set it up. And also I want to do where like it's completely populated, like find a place in China that will populate the boards ready to go. They'll ship them to you, right? They'll cost more, but they'll ship them to you. You pop the batteries on, you make them. So like all levels of DIY. Some of you guys are crazy. You guys can like design these boards in a couple hours. You just needed the idea. You're gonna do that. You're gonna order your own and make custom, all the way to like I just want to be able to pop some batteries in the thing, and and then ready to go. So that's my aim. Anyways, I've never actually done. I've been in like product design and manufactured in the past, but it's always been like aluminum parts. It's always been like this junk. You know what I mean? Like I designed this, and then I had a shop cut it, right, and then I productized it, and I sold it, and it was great or whatever. But this is a completely different kind of product. This is just metal, aluminum parts, right? Custom aluminum parts. It's all mechanical, like, right? You have to like design how does the metal bend, how it's a clamp on the thing, the weight, the strength. This is a completely different beast, and I've never done it, and I thought this is a simple project that that I can tackle, and there's a need for it, and so I think you should talk to Stotty from Strange Parts channel. He lives in China. Scotty. Okay, Scotty? Well, yeah, I think I've been thinking about like who's told me like, hey, if you ever need something made in China, just let me know. I hear that all the time, and I'm always like, oh yeah, I'll let you know. And then just in the back of my mind going like, I'm never gonna make anything in China, Never had the thing. In fact, when I was doing the parts for Jack 35, I was a no China guy. I'm like, no, these parts are gonna be designed, milled, you know, completely productized from beginning to end here in the States. You know, I don't want to send work to China, but this is different. Like this is there is a PCB maker here in the States, and I got a quote from them, and they're the ones that used to make all that stuff for me too. And it just not competitive, right? And then if I do it here, then I have to find third parties here that would then, you know, populate and stuff. And so that's gonna make the cost skyrocket. And so JLC PCB has boards for $2. Yeah, that's where we ordered these. These weren't $2 for 10. They were like more because they're larger, right? And but the cool thing is that they do like really large boards. They have capabilities is actually pretty good, and they have like you can do custom colors, you can do like really thick layers, right, to carry current and stuff. But all the stuff just starts costing a lot of money, and so we're trying to build a system here that doesn't add a ton of like cost to the batteries, right, and eliminates the time. That's so those are goals here, and we gotta try to fudge our design to be able to meet at least some of them, you know, halfway. Like I don't think we're gonna be able to, you know, meet all of them like 100%, but you know, some of them. Let's see. If I put two Samsung 25 hours 18650 parallel, does that continuous amp doubles? Yeah, if you parallel two of those cells, that would double your output of those pairs of cells. Dangerous Prototypes is also in China and run by Westerners. Dangerous Prototypes. Oh, is that like a company? Is that what they're called? Sorry, because I haven't been reading the messages, so you'll have to retype the thing. I love JLC PCB. Yeah, that's a cool website. I have a few websites that have reached out and they're like, we want to sponsor any of these products. That's how really this thing started. I thought I had my idea, and then a couple of these websites, and so then I sent that to Justin and be like, hey, can you like do? They want to do it, and I think he checked the prices, and he seems to think that JLC PCB was way better. And so then when I ordered my first batch, then I just used them too. PCB Way is actually the company that offered to sponsor this project. I think, you know, just for sample. I think that's all they would do, like do sample things, and then silver and gold pads. When can we get some test boards in Australia? Well, soon. As soon as I have them, I'm gonna have them sometime this next week, and then I'll do the button, do the thing, and then you guys can order a few just to test them and stuff. And then, because I have a lot of changes that I want, right? So I have to get with Justin and see if he can help me do those things. If not, I have to figure out how to, because I don't know how to edit the Gerber files. I thought you just be able to do them, but I don't know. Someone said that maybe Eagle has a feature where you can actually import Gerber files and then you edit them and then you export Gerber files again. But it just doesn't seem simple. Like if you just Google like how to edit Gerber files, it doesn't seem like Gerber files are editable files. They're like output files, right? If the stream is laggy, again, force your browser down to 720p. That should help with that. Because right now your browser's trying to do it at 1080, and yeah, I'm too slow for 1080. It just cannot. It cannot withstand or whatever the thing is. Okay, so you guys are just typing in like crazy fast. PCB will be open. Hopefully we can order directly from JLPCB or something. I wish they had a thing where like you submit the design and then, you know, like then they just sell it to you like a little storefront. You know, here are like designs that people have made open or whatever. Like the other company that I did all the custom metal work like that, you design and you can submit that design to be there, and then anyone could be like, give me 2 of those, and then, you know, they would make them and stuff. They take the file they already have on file and then just do the thing, right? So if you guys out there know of anyone that will do that for us, like they would take like a PCB, like maybe we can like print it or have it manufactured at our gel PCB, and then they send it over to the third party, and then they like, you know, they have it there available for you guys to purchase, or they can like populate it and then have like, you know, all the stages. That would be super awesome. I don't know of any of these services because like I said, I never used it. So like max headroom. Let's see. We need a gigafactory in the UK. Yes, we do need one of those. Why can't they make larger lithium-ion cells like prismatic? They can. They do all the time. We have, yeah. Tom has those lipo ones. The pouches, they're like 8 amp hours, right? You can parallel a bunch of those and make them however big you want to do it. No, my PCBs do not include a BMS. A BMS is to be done outside, apart, because this is highly modular. So one BMS might be good for one application, might not be good for another application. So definitely, or we could kind of do it like per module, but then that kind of adds up because what? How come I can't recall stuff right now? My brain is like dying. Is it because it's hot in here? Let me see. Let me take some out. You guys are going too fast. I think my brain is it's cooking. 200 of you guys. Wow. Thank you for joining me in this laggy stream. My computer is having, trouble. I guess I'm going to have to order a new one of these guys. I busted it being stupid. This is $1,000 and this is the best streamer. Like, none of these problems used to happen. There was never laggy because this thing will actually take care. Like, it's an actual software, hardware encoder, right? So now I'm using this piece of crap computer and it just sucks. It's always just kind of sucky. Maybe, let's see, maybe if I shut down, quit Google Chrome. So I just quit Google, the Chrome thing. Let's see, main screen. Yes, I mean, CPU is not that bad. It's using 35%. And it's sustaining 2200. Oh, let me see. What if let me see if I can try to do the thing. Okay. What if we do 4,000? Okay, so I just changed it. Oh, look at that. Then it went slower. Okay, 2,800. All right. Hopefully it's going to be better. Maybe not. Okay, so maybe that helped. Yeah, this definitely will stay on replay. Like, the thing that happens here on YouTube, it just saves it for you. You don't have to like do anything like over there on Twitch. That's one of the things that I like about this. Can you explain how to calculate the amp load per cell once the pack is built? Amp load per cell? The amp load per cell. Well, I mean, it just depends. Like, you just count the amount of cells you have parallel in your strings, and then that's how much you can put, right? But you should calculate it different instead. Like, I mean, that's good to know how much a pack can put out, but you should really. Oh, the overlay. Okay, let me try to turn off the overlay to see if that helps. Main overlay off. Wait, should I just turn it off in the thing, in the feed here? Will that actually help the thing? I don't know. We'll see. Let's see what that does. Are you and Justin going to publish the gear files? Yes, we are. I keep saying that. Why you guys keep asking me that? I don't know why. I've said that like multiple times. The CPU is 35. Then it's a bandwidth issue. Yes. There's too many of you watching. You guys are hogging this thing. Okay, so now the bandwidth's a little bit up. It's like at 37. But yeah, see, it's just fluctuating all over the place. 35. You know what? I should check to see if my phone actually has better bandwidth. Sometimes this works a lot better than the connection. And if that... Because I'm capped at 10 megabits up here on that, right? So let's see, I'll put the thing, go. Okay, let's read some more of your questions. Can I use a laptop BMS for something? Oh, you mean like the BMS that comes off laptop batteries? Like, no, those are like kind of closed systems. If you're good at hacking, if you can like, you know, flash the software inside those chips, yeah, you could do it, right? But like the average, a regular person can't. You know what I mean? Like you'd have to be like talented in that form. Okay, so the oh, wait a minute, that the upload's 10, right? But that's okay. I forgot to turn my thing off, my Wi-Fi. Let's do it again. Come on, do it again. EC EDA looks good. Just click on the little icon. What did you guys say? Let's see. Just click on the little icon next to the overlay one and sources. Oh, it didn't take it off. Okay, let me transition. No, so I actually turned it off. I think now I just have to like transition to it. Yeah, so there it is without it. Okay, there we go. I can't cut it and I can't change the settings on the stream anymore. Once you like go live or whatever, once you go, I would have to end the stream and then like start it again or whatever. That's why I didn't want to do that. Why do our mobile phones use only single cell lithium battery, whereas laptops use multiple cells? Because they need higher power, right? And so the way to get higher power more efficiently is to have higher voltage. So you'd have to get the voltage higher than 3.7 volts nominal for a single cell. So that's why they have to do that. Take the MacBook off wireless. Well, that would be hard because I'd have to run. Yeah, in fact, you can't. These new MacBook books don't have any ports in them. Well, they do. They have USB-C. I wonder if there's a USB-C to like RJ45 that you can like. Yeah, I'm sure maybe there's a thing that exists, but I don't have it. It doesn't come. ECEDA gives an order form from JLC PCB button. Yeah, but it's an that easy thing. That's just like the software, right? That's just the design software, like easy. Is it really that bad? Am I like just not like? Oh, it's just like all over the place. What was it on the phone? Let's see here. Friggin' YouTube. It wouldn't take the same settings as the it's over there on Twitch, right? On Twitch I kind of had gotten it already, got it down. But then now YouTube didn't want to accept those settings. Oh, so it is, huh? Oh man, that sucks. Well, oh yeah, look at that. People are just like logging off. Well, I guess if it sucks, maybe we shouldn't put it. Oh my god. Like, yeah, it's red, it's green, it's yellow, it's 27, it's 12. Oh yeah, and on the phone it's not any better. It's like 2.7 megabits upload. So yeah, I don't have the bandwidth today to go up for some reason. It sucks. Settings, let's see. Let's force this guy to go output. There we go. Yeah, let me go back to 1,000 because that's what I used to have it at. Boom. Back in the day. Like some background processes are slowing things down 5 to 10 frame rates. And then a lot of lagging. Okay. Well, Even if you like go to the, if you force your thing to the lower frame rates or the lower resolutions, is that what is happening here? This board is only good for Powerwall type situations. Yes, that's what it's being developed for. So right now is that's what I'm trying to do. Yeah, I get a, yeah, I'm thinking I might have to get some dedicated hardware. So yeah, so I just lowered it down to 1,000, and then now it can probably sustain 1,000, no problem. Oh, 13 frames, 16 frames. So that's what it's actually outputting. So I think that's just, that's the encoder here. 17 frames per second. Yeah, so it's gonna just keep doing like that, but I think it's gonna be a little bit more stable. So even at 144p, it's lagging. Okay. Well, that sucks. Freaking connection problems. That's what's gonna mess up this stream. It's not the trolls. It's not the lack of people showing up. It's gonna be the connection. So how's the high current coming off the boards? So they get passed to the other boards. Can we connect the terminal straight to our bus bars? Yeah, so each board will dump their power onto these standoffs, right? And these we can get them like aluminum standoffs, or we can get, I'm trying to get the ones that are mass produced are the what do they make them on? Like, so yeah, so they make them in aluminum, and they also make them in like in bronze. So I don't know which one has more connectivity. I think aluminum does. And they're super cheap because they make them for like all these computer cases and all that stuff, right? And so I want to get those. And so I'd say you could probably do like 10 of these boards, and then we can load it up and see how, you know, what that does. And then that's going to determine like how many of these boards we can do and how hard we can push them. So I know that, again, I know that we can safely push 100 watts off of each board, right? So 10 of these boards you could get 1 kilowatt, right? Again, but that's like worst case scenario, because you don't want to discharge in Powerwalls. You'd never discharge at a rate where their battery's only going to last an hour. Like, no one wants to build a battery good enough for only 1 hour. I mean, that's not a Powerwall. That's a battery, some other type of battery, right? You would call that a power pack or something. And this is not designed for that. This is designed for the purpose of like people building a big battery thing for your house. And then for that application, like I said in that one video, you are going to discharge your batteries at a slow rate, and that's why this is worth it. So then, I mean, we can take another PCB and then like optimize that PCB for, you know, high current applications. Just because, you know, I don't know what the rate is. How many of you guys are going to want to do high current applications, and then how many of you guys are going to do Powerwalls? I think the guys that are doing the Powerwalls are going to want more of these boards. Hold on, guys. Let me take a... Okay, I'm back. Sorry, guys. I just have to say hi to Crystal. She came in. Okay, so what's going on? Oh, you know what? I can hear that. Hold on, guys. Let me close the door. Close the door. It's just a bit noisy out there, and I don't want you guys to be listening. I don't want to have sounds from copywritten material, because then I'll get banned again. The TV's on the other side. I've been that road. So it's not cool. Food's here. No, I wish food was here. She didn't bring food. She just got something else. So why not 24-volt battery packs for solar? It looks like it fits 24 gel cell charging profile of solar charger. Very good. Yeah, that's what we're doing. We're doing 24 volts for that same reason, because you can use 24-volt systems and 48-volt systems by putting two in series. Can you run the big boy inverters off of 24? There are big inverters, you know, 4, 5, 6 kilowatt, I think, inverters, 24 volts. But you wouldn't want to do that. You probably want to do 48. When you're running, like, you know, anything larger than 3,000 watts, I think it's just a lot. It would be a lot better. Unless you have it, unless it's super cheap. And they are super cheap because they're mass produced, right? There's like a lot of these RV, like, people that use them and stuff. And so yeah, you gotta see which ones you find. What do you think about the 3-phase induction motor, less than 1 horsepower for personal electrical vehicles, scooters, bikes? What do you think about the 3-phase induction motors? I don't know if I've seen any induction motors. All the ones that I've seen, come on, these dogs, are BLDC. So these are not induction motors. These are actually DC motors, right? There's a difference there. Induction motors don't have magnets, and all these little ones have permanent magnets. The skateboard project is going. I haven't cracked the holy grail. I have one last thing to try, and then if that doesn't work, then it didn't work. And I'll be making a video about failure and not success. But that's coming. It's coming up. Why is everyone creating skateboards? The idea is sold already. Well, yeah, but who's doing them cheap? Well, I don't know. Did I add anything to that? I don't know if I added anything to that genre or whatever. There are people doing DIY. But I don't know. Maybe I introduced a whole new audience to the idea. And by the way, I had zero desire to, like, skateboard or whatever, but these things are so fun that once you, like, get on them, you ride them, you're like, oh, these are cool. Misa, my brother, is a perfect example of that. He came by the other day, got on it for a couple hours, and he's like, oh, I'm building one. So, you know, it's a thing like that. All of you guys probably don't have any interest in skateboards. You guys are just here for the batteries or the Powerwalls or the electric cars. Who knows? The thing is that there's a lot of you guys that are here for a bunch of reasons. The stand-ups are electrified. Yes, the stand-ups are what will transfer the energy from one to the other one. You could also use XT60 connectors. The spacing here works, but those are more expensive and they can carry probably less power. I think these could carry more than 60 amps, no problem. Those are rated at 60, right? So again, like, you can do both. You can, like, use, like, plastic ones or whatever, but these are just the holes here have terminals on them. So whatever you put in there. So if you had one board, so if you had this board and you didn't want to use this connector, right? Then you can put a screw and a ring terminal in here and a nut, and then that's, you know, that's where your terminals are at. And let's say that you want to remove a bunch, like a lot of power, like run high current application, then you can do the same here. Like, you can run a ring terminal from here, and then, like, I don't know, 5, 6 boards down the line, you can put another ring terminal there, and then you have 2 cables, and you're grabbing the energy and removing it, you know, from several places in the line of these, you know, this module. And I'm trying to do it so that the negative is over here on this side, because that's the closest path to the most negative of the cell, and it would be symmetrical to the most positive terminal here being really close to the most positive of all the cells. So basically these cells go this way, right? Positive, negative, positive, negative, positive, negative. So they zigzag, zigzag, positive, negative, negatives here, So then if you do that, then the terminals are at equal distances from the cells. And then that way it doesn't add any more trace resistance, right? Because it does make a difference. If you look at my last video that I made when I loaded on to like 400 watts, you could tell that cell number 7 was lower than cell number 1. And I don't know, I haven't really thought about it to explain that phenomena, because if there's more resistance in the cable that is leading off of that cell, I don't see, so maybe the cell has to push harder, that's why the voltage is lower, to output the same amount as all the other cells. But it's a circuit, so they all should push at the same, I don't know, I'll have to look more into that. If you guys know the answer to that riddle, do let me know. But I do notice that on that board that was happening, right? I wanted to try to replicate that same condition and see if all the boards do it with all these cells, right? And maybe it's just these group of cells that just happen to be like, but no, it was pretty linear. Like number 7 was lower than number 6, but then number 6 was lower than number 5, or down the line, up the line, let's see, changing the negative path sounds like a good idea. Yes, I'm a gringo in Puerto Rico, says Denise. Or let's see, Thomas Blacking, are you on opposite sides of the boards? Wouldn't that be good enough? No, right now they're on both sides of the boards, the positive and negative. We'll have to kind of redesign the traces a little bit to put the negative on the other side, crisscross from the other side. And then maybe if we can do it, then it should be good where like this side is positive, right? This side is positive, this guy is negative. And then we can use both of those, because there's 4 standoffs here. We should use them, right, to carry the current. Because it's a more solid connection, less chances of, being extra source of resistance and thing. And you increase the chance of then getting higher, output out of the board. Cheers. If you have a moment, could you explain matching IR in an example, a 10S 6P pack? Understand matching each parallel group total milliamp power to close, but how to match IR? So the same thing. You gotta match the internal resistance. So basically, internal resistance is just the ability to push power out, right, of a cell. But if you have 20 cells in a group connected in parallel, then the average of those internal resistance, it's going to average out to whatever it is, right? And so now you have to make sure that all your other groups are the same or closely match in the ability to push amps, right? If you have one group of 20 cells that really sags really low at 5 amps, and then you have another group that like, oh, you can load it up with 15 amps and it doesn't, sag at all, then, that weak group of cells is going to be hurting, right? And it's going to be running, actually it's not going to be run, the one that can push more, it's going to be hurting because it's going to be more stress. It's going to be hotter. It's going to reach the bottom first, right? That group. And then you're going to run into trouble where like the rest of the cells are still in the range of healthy voltage, but that group right there is on the thresholds or reaching the thresholds faster, which means you're just killing them faster. And that is going to cause an imbalance or whatever for the thing. Oh, Christina Virgona, thank you for the $5. Thank you for your super chat. Does balancing work correctly? The first, second cell, etc. is connected in line, the boards above and below. Yes, number cell is connected to number cell of the board adjacent to it, and etc. etc. It's just number 2 is connected to the number 2 of the next board. They're all connected, so it's 7 groups of cells, no matter how many of those boards you put on. What's going on? Yes, I will make the Gerber's file available as soon as I finish the design. I'd still want some things to be changed. Let's see. Jordan Lan, how important is balancing in LTO pouches? What's LTO pouches? I don't know if I know what that is. 2 of 10S in series is 72 volts. 2 and 10S. So these are 7S. Active balancing. Yeah, so active balancing will be available. You will be able to do that with these boards because it's going to be up to your BMS, right? And of course, these little traces for the BMS are small. I guess we're going to have to test them to see at what rate you can. Well, they'll do 4 amps. That's what Batrium does, right? The maximum. I think they can do 4 amps. Although he's working on a newer one, might do more than that. I think he said like 8 amps or something. Or is it 8 watts instead of 4 watts? I can't remember. But I think those will be good enough. Like all the balancing that ever happens, all the on all the BMSs is really low. You're talking about 100 milliamps, 200 milliamps, kind of those kind of rates, I'm trying to use a 200 watt 3-phase induction motor on a scooter. I need to design a boost converter to elevate 24 volts to 300 volts. I buy 120 cells in an eBay. Oh, that's crazy. Why? Yes, you want to get it all the way to 300 volts. I don't know if you have to go that high. I mean, I don't know. I guess I'll have to look at what you're doing, but yeah, I mean, you're using an induction motor, huh? Why are you using such a small induction? Just use the permanent magnet motor. Let's see. Do you need a special charger to the 1860 cell packs? I need the BMS. No special charger. Any charger that would charge 7S could be used. Yeah, if you use one that has active balancing, then you don't need to. But yeah, you could also use a BMS. Yeah, and you will need a BMS if you're charging off of solar, or if you're charging off of like any other charger that's not like an RC charger that has balancing leads. Oh, who is that? Is this stuck? Oh, this is stuck. Welcome back to you. Thank you for the $5 in the spot. Let's see. Oh, lithium tinnitate. Yeah, I don't know. I don't have zero experience with those batteries, right? Because they're like, I don't know. They're I don't know what's special about them. I never come across them. I've never used them. All I know is lithium iron phosphate and lithium cobalt oxide, whether it be like, all the variances that are on those 18650s. Do you have the schematics? No, there's no schematics. I mean, I guess I should make a schematic of the board. It's super simple, really. There's nothing to it. Will you be releasing the 14S PCB along with the 7S? I don't think we need to, right? Because why would we need to make a special 14S when you can use 2 of these parallel, put it in series, and then that's your 14S. Why make 2 boards when you can have 1, right? And you just double up. So if you order twice as many, then you can cut down on your costs. So yeah, I mean, we can design another one, but it's extra work and stuff, and if it's not necessary, kind of thing. The induction motors are better in long term because they can handle any amount of high temperatures. Well, that's true, yeah. Yeah, you can heat them up and they won't demagnetize and all that stuff. What's the maximum current to recharge the cells? Depends on the cells. You have to look at the spec sheet. Some cells can charge really fast. Some cells can charge really slow. Why are you making your pack 7S? Well, you make different packs available. 7S is the lowest voltage that you can do to mimic lead acid batteries. So all this equipment that's made for lead acid batteries can't really work with lithium unless you get up to like 24 volts. Then that's 7S. This is 24 volts. There's not really a lot of 36 volt equipment, but 48, right? And so 48 14S would do it. And that's why I'm going that, because then it allows you to get a lot of the equipment that you might already have, or you can easily get it, you know, in the market. You don't need no specialized equipment to use lithium batteries. 7S, and then you put 2 of them in series and you get 48. So that's why. Let's see here. Thomas Brecking, thank you for the $5. Do you have any suggestions on a 400 to 600 watt inverter that can be easily taken apart and put into a portable power solution? So the one, which one is the one that I used one on my video for the Puerto Rico thing, but that was 300 watts. And I actually, did I take that apart? Let me see. I don't remember now. It's been such a long time. Let me look. Oh my God. Ah. Here we go. Here's my thing. I did take it apart. That's right. It's really small. And I took it apart and then I just screwed it on the top of this thing. Here I'm trying to change this, right? These are those lithium iron phosphate cells, which that's another thing that I'm gonna try once I get all the boards. Yeah, by the way, so to answer your question, the only one I have in experience is that one. Go back and watch my Puerto Rico 400 or 300 watt or yeah, solar 300, I don't remember what I call it. It's like solar Puerto Rico emergency power for Puerto Rico thing video. I made that like, I don't know, 6 months ago. I have links to that inverter there. And it was the smallest, cheapest sine wave inverter that I could find. It's actually really, really cheap. So the 26650s are actually the same size, right? So you could use them, except that these are different voltage, and so you don't want 7. So yeah, you would have to make another board that is not. So you would want to do like 4 of these or 8. Oh, one more and it would work. But they're bigger, so you would have to space them different. But anyways, like these are available. I think there's still some, and I think the guy, I haven't been pushing them, so the sales went down, and I think he lowered the price. So if you need lithium iron phosphate batteries, I think there's still a bunch of these like 26650s, full river. Did I include those? Yeah, I have included those. I have a link in this video where it says where can you buy batteries. It's right here. It says lithium July. There's links to those in there. I think they're like $60 for 80 of these cells or something like that. That's lower than what he used to sell them for. And then we could just design a board like that. I don't know if it's worth it because I don't know how many of them are. I haven't like looked. 18650s, there's millions of them in the world, but these 26650s. Let's see here. Oh, let me see. I'm living a sailboat. Currently, I have 200 kilowatt lithium battery. Can I add a Tesla Powerwall into the boat? Thanks. You have 200 kilowatt lithium battery. 200 kilowatt? Like you have 200 kilowatt hours now, right? What do you mean with 200 kilowatt? And you want to add Tesla Powerwall into the boat? Yeah, you have to explain. I have a 4-pack STL for the 26650 300 cells. Okay, let me go forward here. Having trouble finding a motor to convert a 10-inch scooter to electric 18650. Can you recommend one? Just get well, that's the thing. I still don't know if I can make those motors go fast. So there's a and I haven't found the so there's a hoverboard that has 2 10-inch hub wheels, right? I'm not familiar. You can't find them. I think on Alibaba you can find them kind of cheap, but I think they're like $50 or something, and then like it's like a $40 to like ship them, right? So you're talking about like almost $100 for a single wheel, where you could just buy the hoverboard for like $150, and you already have the battery, and then you have two of those motors, right? So I think that would be the way to go. Now you just have to undo the battery because you can't use it. It's probably a 36-volt battery. I'm not entirely familiar. I know all the little ones are, but I thought of doing that, and then running like another, like a Vesk, for example. You can run that all the way up to like 48 volts. That's the only thing I have yet to try on that hover skateboard. And see if that will get, because I tried to up the RPMs, right, on the Vesk, and it just didn't do it. But I'm still pumping it like 36 volts, so maybe that's the reason, the limitation on the RPMs, 10 miles per hour, right? It's in the voltage. If I put another 10 volts, go to 48, then I might be able to do it. But I haven't gotten around to do that. So I can't really recommend for you to get one of those, because you might not be able faster than 10 miles an hour. Unless you don't want to go faster than 10 miles an hour, then I'd say just buy a $150 hoverboard. Take those wheels out, put them in your little scooter, and then you got two wheels, like dual drive. That's 10 miles an hour, and you did for $150. Let's see. Okay, are the things getting down? Oh, 193, 192. Let's see. Okay. Con, where's a good question? Somebody ask a good question. What about a tester that will discharge those LiPo4 batteries to 1.6 volt? All I can find is cut off to 2.3. 2.3. Is 1.6? Yeah, I don't think there's much down at 1.6. Did I do? I haven't done. I haven't done a discharge test. I'll do a discharge test. I have a battery there that I soldered a connector there, so I can very quickly connect it to my charger there and then just run a discharge test. I think from 2.3 down to 1.6, there's like nothing there. So you might not want to go down to 1.6, because that's where all the damage happens, right at the very edge. But that's where the least amount of benefit you get. So you don't get that much energy between those two voltages, but you get like all the damage that the cell's gonna receive. So you might be just better off staying at 2.3. And if you're looking for a discharge test or something like that, yeah, I don't know. I haven't tried that. I think if you're doing the test, you're just probably looking about how much energy is left in there, right? Is that why you're trying to do that? We need Discord. Do you know a cheap way to build a 2 kilowatt charger for a 12 volt system? I've heard someone put those cheap eBay LED drivers in parallel. That's 2 kilowatt. Let's see. Yeah, you might just find one. No, but that really, like a right? Like those. I wonder if you can parallel those. Yeah, there's a way. Like you gotta find some that are isolated and then parallel them. That's gonna be the easiest way. Let's see here. Are there balancing boards for headway cells? Are there balancing boards? I want to make a bank for my car audio. Gonna need 1200 amps burst with 300 amp alternator feeding it. Yeah, there are. It's just like any 4S lithium iron phosphate BMS will work. Just you gotta search for it. Most likely like an Alibaba or something, like AliExpress, something like that. eBay, you'll find one on eBay too. Regarding the tester Opus C3100 version 2.0, You forget the... Oh my God, what happened here? Forget the restoration, turn the bus into a party bus. It is a party bus. I party in it all the time. Every time I get on it, I feel like it's a party because it's so fun to drive. Because I send it a message in Facebook trying to explain the 3-phase induction motor. I hope I can explain, you know, some things about it. Okay. Sorry, I don't get to read all those messages anymore. It's just too many of them. Let's see. Do you think everyone watching you wants to make a Powerwall? I don't know. I find it strange that so many of you guys are watching what I'm doing. I'm still just a regular guy just messing around. I think these like batteries are like the most awkward thing. Someone asked me yesterday, what do you do? Like, what do you talk about in your channel? And I was like, honestly, it's hard to explain. Like, batteries. You know, like, I talk about batteries, like solar panels, somewhat. You know, like electric cars sometimes. It's really hard. Like, I don't know. I think I'm selling, like, I mean, DIY. It's essentially that's what I'm selling. Like, I'm selling lifestyle of DIY. It's like, take something, try to do it for like nothing. Try to do it different than everyone's doing, and then see if you can hack it. Right? It's like life hacks. Don't buy the thing because most likely you can't afford it, or if you can't afford it, you want to learn. There's a bunch of reasons why you don't want to do it, but then like try to find a hack. Something that someone else is not using. You know, get something that's super cheap that someone else is building for something else, and then take that and then use it to your advantage. You know, and so that's what I'm doing. So yeah, I don't know how many of you guys. There's like 200 of you guys watching right now. Are all of you guys planning, if not building already, a Powerwall? Are you guys planning a Powerwall? Because that would be super interesting to see, you know. Am I in focus, by the way? Let's see. Oh, does it tell me when I'm focused? Come on, camera. I can't even use my camera anymore. That's the old camera. Sorry, my new one. I still haven't sent it in. I have to get a new one because I busted it. Let's see. Okay, there's a lot of questions now. It is interesting to watch and someone to build battery packs and other EVs. Discord for video and audio. How would you recommend charging a large-scale version? How would you recommend charging a large-scale version, 10 to 10 kilowatt hours, of a Powerwall built with the PCB modules? No solar yet. Okay, so if you're going to do... What voltage are you running? If you're going to be running 48 volts, then probably the best way would be to get either like a 1500 or a 2500, or you can even get 5000 or get a couple of the 3 of the 2500. Whatever you want, at whatever rate you want to charge your battery, right? The Elcon chargers. So those Elcons are really cool. I have one of those. I have actually two of them, one 5K and one 2.5K. So I charge my bus right now at 7.5 kilowatt rate. And that's pretty cool. That's pretty fast. And those chargers are really cool, and they can do like all the way from like 48 volts all the way to like 400 volts. So that's pretty cool. They are, I mean, I guess maybe some of you guys might consider them kind of expensive. I think, yeah, so the 5000 one, it's like $1,200, $1,400, something like that. Like over 1,000, but less than 1,500, somewhere around there. And the 2500 is, yes, like 600, 500, 600, something like that. So that might seem like really expensive for you guys. A lot of you guys are saying like a BMS, $600 is too much. And I'm like, I don't know, you're putting a 10 kilowatt, you know, you're putting a giant battery on your thing. $600 is not a lot. So I think those are the ones that I have experience with. The other ones that I haven't tried, but probably run about the same. So there are what is it, like 2,000? I think there's like 2,000 watt like server power uh, power supplies, right? So the big servers, computers, I run on 48 volts, and they have these like things, and they sell them. I know they sell them. So you have to like do some like little conversion or something, and they sell them for those chargers, right? Because my charger there can do like 1,300 watts. If you can like put two of them together, so now you're talking about 2.5 kilowatts, right? And so you need about 24 volt or 48 volt power supply. So they're like really cheap. I think they're cheap. I want to say they're like what, $100 or something, or I think less than $150 for these. Like they're like refurbished, like you know, server 48 volt server things, and that would be another way to kind of look at it if you're doing 48. I think. Let me see. Let me take a drink here. Oh my God, let's see here. So where are you storing the module to keep the current safe? Oh man, I don't understand that. Yes, you're in focus. I got 5 of those, 40 volts, A123 cells from Tom. How do I test the total parallel amp hours? Well, so I would test one of them, right? That's the crazy thing though, because they're what are they? They're like 12S, right? That's the problem. That there's not a lot of chargers that can do 12S. Yeah. So I know the ones that Tom has a BMS on them, and I don't know if that BMS just works like a regular BMS standalone, or you need to take it off and just like install another one. But what I would do is like just put like a charger, it's a 40 volt. I would get like a 42 volt power supply, and then you charge it, and then you put a meter and you measure how much current is going in, and then you can like, if the BMS works, then it's good. It'll balance it or do the whole thing, right? But you got to figure all that out. I actually don't know, because I haven't got my hands on any of those batteries. And if they don't, then you can just use like a little cheap RC thing where you can like monitor each cell so that you can make sure you're not killing any of the groups if they're like way off. But you basically have to measure how much energy you can put in, and then how much you can get out. And that's the important one, how much you can get out. Yeah, you could just get like I have a bunch of these. Like every time I find another one, I'll buy it. You know what I mean? Like this is a little thing. This one's cool. In fact, I think I'm going to use this one to monitor the battery on my next project, because it's got a temperature sensor, and it's Hall effect. And you can, a lot of people were complaining that the Hall effect sensors are kind of inaccurate. This one has 2 little pots here that lets you adjust it. So you can put your clamp on the cable, and then you read the clamp, and then you read what this thing says, and then you can like manually adjust it. And by the way, this is like $30 or something. And they're like, it's wireless. You can put this in one box, you can put this in another box. You power it via USB. And yeah, this is pretty versatile. It even has, I think it has outputs here to like control like a big relay or a contactor or whatever. So this is pretty powerful, and you can use these, any of these. There's a bunch of different versions. Oh my God, look at that! My battery's about to die on my camera. Let me change it. Here's another one. Let's see here. I'm gonna have to turn the thing. Break. All right, and we are back. I just changed the thing, and yeah, that camera sucks. Let's see. What are we doing here? Let's read some more of your questions here. Hello from Croatia. Dead battery. Yeah, I know. It's always. Usually I run it off of a big battery here, but today I just didn't do it. Let's see. What's the limit DC we can work with in Australia? I don't know. I don't know your lands. You'd have to ask your Australian. Wait, what do you guys call each other? You guys call each other thing. Are there any problems related to using sub-C batteries? 1.2 volts, 400 milliamp hours, 10 in series, parallels, portable power box. 86 are way too expensive in Norway. No, you could totally use what are those? Nickel metal hydrate, right? The 1.2 volts. Yeah, you could use those. No big deal. What do you think about Elon Musk underground tube rail project, the Hyperloop? I think it's totally possible. I think any of the other projects that he's embarked on, I would say you're crazy, and would not have believed them until now that he's doing them, right? So this is no big deal. I think he could totally do it. I think it's just a bunch of people that don't believe in the thing that is the problem. So, have you? Let's see. About car audio and electronic car, is a high power audio system not practical in an AV? A 2000 watt sound system would need 14.4 volt, about 200 amps. Yeah, so you'd have to set up the 12 volt systems. You'd have to beef it up. There are DC to DCs that you can connect to the main pack, and then run 2000 amps off of there. I mean, you're like, our battery packs are used to like providing like 80 kilowatts, right? 80,000 watts. That's what my bus, like my battery can't supply my engine, right? Like a Tesla can do 400 kilowatts, 400,000 watts, right? So 2,000 watts of audio, that's nothing. I mean, they're laughing at you. They're like, whatever. You can do that in my sleep. But you will have to install the right equipment to do that, right? At 12 volts, that's a lot of amperage. So you'd have to like have beefy cables. Not so much beefy cables coming into like a DC to DC, 2,000 watts. 2,000 watts, is that what you said? Yeah, 2,000 watts. High voltage is like, regular cables. But then at 12 volts, they have to be like beefy cables, yeah, you could totally do it. It's just, it's just another project. You have to find a DC to DC that is capable of doing that, or parallel a bunch of the ones, like the ones I have. I think mine is set up at, I don't have a big one. I think I have like a 400 watt. I think I have like a 400 watt. Yeah, like 12 amps or something. I don't have like a big one. And then I have a lead acid battery in between that, right? So it takes the high voltage from my battery, lowers it to 13.8 or whatever from the 12 volt battery, and then it just always keeps that 12 volt battery charged, 13.8 or whatever the float is, whatever. And then whenever I use stuff for lights, audio, whatever, it takes it from the battery. But then if it's less than 400 watts, then it basically takes it straight from the DC to DC that's on. But if it's more than 400 watts, I think then that energy, the difference, right, between 400 watts and whatever I'm using, comes straight from the lead acid battery. And then, so I only have, like, if I'm using more than 400 watts, I only have, a few hours that I can do that continuously until the battery depletes. And then after that, it sits there and it just puts it right back, at a rate of like 400 watts. That's just how that works. Why don't you do 12S so you could just use a normal 12 volt BMS? I don't know what a 12 volt BMS is, but there are standards that we're trying to hit, and you can hit the 24 and you can hit the 48 with 7S board, because you can just use one single 7S, or you can double it up in series and then do 48. That's the reason. I don't know what a 12 volt BMS. There's BMSs of almost every configuration. 7S, there's like 8S, 6S boards, there's 10S, 11, 12, 13, 14, 15. I even saw a 16S board the other day. So yeah, that's not a big issue there. But the more important thing is that you can have like inverters and stuff to use. Are there any problems? Okay, so I already answered that one. Where are we at? Okay, there we go. Here we go. Another question. 100 volts DC is the maximum legal before needing the system to be certified. Woo! Okay, so there we go. In Australia. That actually sounds good, because yeah, why do you need 100 volts DC? I mean, for efficiency, obviously, right? But yeah, no one needs to be, I mean, yeah, someone needs to know what they're doing if they're going to be doing, that high voltage DC. That's where it starts getting like dangerous. Let's see. 4S would give you more headroom. Most amps will handle higher voltage. So that's not for me, right? Are the cells connected in series or parallel within the PCB board? It's a 24 volt PCB, so they're connected in series because cells are 3.7 nominal. I want to change the batteries in my golf cart with your DIY power pack. Yeah, I don't know. I wonder what the power requirements are for a golf cart. Try to find out. Maybe it's possible, because you can have what's the voltage and what's the power output. You probably could have like 50 of these boards in there. Oh yeah, right, they usually have like huge batteries. You could probably put 100 of these boards in there, and then yeah, they could feed the constant current, right? The 1C or whatever. Let's see. 130 DC requires certification and quick disconnect. Bird's nest. Miss what you're using, AA or AA. Oh, I see. Yeah, these are not for A or AA, right? These are for different size batteries. So these boards are going to be too big for you. You're going to be wasting a bunch of space. You'd be better off like building some other way. There's actually, I mean, those are standard batteries, so there's a bunch of like holders for those that are, that you might find some that are good. 12, 24, and 48 volt on carts, on golf carts. Where can we find more info about power and energy cells? Seen you talking about that in your last video. You might have to get that DIY lithium batteries. I think he talks about that in there. It's just like different batteries. Like there's no set standard that one is a power. It's just some cells are better at pushing a lot of amps. Some are better at storing a lot of energy, right? So they can hold a lot, like more capacity. And it just really depends on your application. But this basically in the you have to read the specs on each one of the cells, right? Like if you're using like a power like a power tool, right? Like this guy here. This guy right here has 10 cells, 5 in series, right? 5 in series. No, it's 18 volts. Yeah, 5 in series, two in parallel. So this thing uses like 30 amps, like, cause this puts out a lot of power. You know what I mean? Like, you're supposed to like be like, so basically, if you have two cells that have to provide like 30 amps or 40 amps, then you gotta have like at least like 20 amp cells, right? And so then you're gonna have to use 20 cells that have 20. So those are power cells because they can push a ton of power. These are power cells, right? These can push out a constant 30 amps for a few minutes because they're really small. They're like 1500 milliamp hours. If you were to use like these guys, which are bigger, these are like exactly the same capacity of two of these fits on this one right here. So these are 3000 milliamp hours. These are 1500. Except these can, together, they can push like 60 amps continuous. This thing can't do 60 amps. This thing can do like mostly like 12 amps. And at that temperature, like at those rates, this thing is like dying. It's too hot and it's melting and stuff. And, you know, and it's only sustaining that for like a little bit and it's just like dropping like crazy because this is not designed to push that kind of amperage. These are. So that's the difference between power cells and energy cells. And you can tell by just reading the spec sheets. Usually power cells are small, although there are some crazy ones out there now. There's you guys probably know which one is that brown one that is like 3000 milliamp hours and it could do like 30 amps or something like that. There's one. There's a couple of them, or maybe 3 or 4, I think. That cell right there is both. It's a energy and a power cell at the same time, right? Like it's a weird, whatever they needed to do in the chemistry, and maybe they use some like exotic like material or alloy in the thing. I haven't really looked into it. But those cells are really expensive. But if you needed that cell, then you can get it. Do you bottom balance your batteries? Yeah. So you know. In my Samba, I did try to bottom balance my batteries, except that they're so well, you know, matched that it essentially bottom balancing really means top balance. At the top, they're pretty even too. Tesla did an incredible job at balancing those, matching those cells on those modules. Oh my god, we've been here for 2 hours. No wonder my throat is like kind of hurting. I'm talking too loud. Why am I screaming at you guys? Let's see. Oh yeah, the LG HG2 20 amps. Okay, so that's that brown one. So that's essentially the new version of this one. Oh, LG, oh, that's the HG2. This is the HB2, LG HB2. This is the old version, 1500 milliamp hours. The other one is 3000 milliamp hours. Yeah, there you go. Battery mooch. He knew what I'm talking about. See, I'm not crazy. Are you a top or a bottom? That's funny. Jay, is that cool if we crowdsource a BMS for this board built out of an Arduino to start? Yeah, go for it. I got nothing against crowdsourcing, you know. I think there are a couple of like initiatives I think that people are doing. There's a couple of systems. Yeah, it'd be cool if you guys can come up with something like that we can use, that you can like build. So the biggest thing with like the BMSs is that you never know, like the e-bike ones are cool, right? Because they're mass produced now. They're getting better. Before they used to just be like a bunch of junk. Now there's like the cool ones. The good ones are expensive. The cheap ones, you know, they're cheap. But good ones are starting to get more affordable. The problem is that there's like very little feedback to the user. And so when you're like on a skateboard, for example, I don't have a BMS of my skateboards, by the way. I don't care. I'm just gonna match them, right? I'm gonna charge them all the way up, and these batteries are like well matched because I tested them, and I'm just using them like that, right? And I'm not, you know, I'm not letting it like completely run out of energy I haven't yet anyways. I just charge it all the way up, and at the top is there. So I top balance those. I probably going to pay the price one day when, you know, I don't make it to my destination. I ran it till it doesn't go anymore, and maybe I kill the group. And I was gonna say something. Oh yeah, so when you're like on an e-bike or when you're on a skateboard, you don't care like what the batteries are doing. You know what I mean? Like, just tell me how much battery I got left, so I know I have 5 miles more or 10 miles more. You know. But when you're doing like a big battery, like a Powerwall, or you're doing like an EV, you do want to know like what the cells are doing, and you know, what if the group is like starting to like show weakness or whatever. Like, you would want to know all that stuff. And with all those like e-bike ones, there's never any feedback. There's never tells you like out of the 12 groups, or you know, out of the 10 groups, whatever it is, the batteries is you're monitoring, just never lets you know anything. It's just you're trusting that it does, and that's kind of a weird. So if you were to do like an Arduino, you would have the ability to like to code that in there and put like a little screen or lights or somehow some like user feedback, so you know there's a trouble, or there's one group going out of range or whatever. That, by the way, that's what like Batrium lets you do. Like, it has all those features in there. It lets you, like, it logs, so you can like literally go and be like, there's somewhere with this group of cells, this module or whatever, and then you can go into the logs and be like, oh, this is started having problems back in April, when it got hot, or maybe like every summer this module like lags behind, or loses capacity. Then you're like, oh, maybe it's because it's getting hot, so it has super powerful, because it's always recording the data, and you can set it up to record once a day or once every second. Like, it's completely configurable like crazy. And so that's why it's $600. But it's by no means it's an expensive product. It's just a very powerful product. If you can make something in between, and I think he's doing one, by the way. He's working on a smaller system that's still kind of powerful, but it's hopefully not going to be as expensive as the other one. We need something right in the middle. We don't need like all the bells and whistles, but we don't need just complete like just darkness. Something in the middle. We just need that. Someone build it. Coders, you guys that know how to code, do the thing. Do the Arduino based one, so we can all buy it, use it. Yeah, I think I'd want to know no, because you could just get off the board and push it, and you're like, okay, get out. Yeah, I don't care. Like, it's just more, you don't care. Like, what's your writing? You don't care. Like, I know we're like this kind of geeks that we like to know, and we're building the batteries and stuff, but like, once you're out, you don't care. Like, you're just right. Like, you just, like in my bus, I don't care. Like, at this point, I don't even check my batteries. Like, it's just, I know what they're doing. I've seen them do it for years now. Of course, maybe I'll pay the price when one decides to like go off and do a thing, right? But for the most part, I know what they're doing. I've seen them doing time and time again, and that's the only thing that BMS will provide. It's that one time that is for the exception, right? That's what the BMS is good. It's for the exception, or like, if you're just totally putting batteries like without paying attention, they're used, they're different, and the exception is going to be there all the time. Like, it's going to, the exception is actually going to be the norm. Batteries are going to be unbalancing each other. They're going to be like pushing each other and stressing each other out and stuff. Then you delegate all that extra work to like a BMS, and you can do it. Like, actually, Batrium was designed for that, to use beat up cells. Let's see. Need testing to make sure copper isn't blasted away. Let's see here. Your boards turn into a rocket board. Yeah, that would be cool. Can you get EV West to list the parts for the Porsche kit on your video? Yeah, we can do that. Uh, that shouldn't be too hard. There's not that many actually. It's like the motor, it's a kit, right? The motor's a kit. The batteries are like Model S batteries. I don't know if they have the BMS available yet. I gotta talk to Michael and see if they already have it. I should play with one of those just to see how it is, you know. And then all the other things are just like normal things. There's that was actually a pretty simple build. Can you get, okay, so that's the one. I'm going through a lot of scrap laptop packs trying to sort good from bad. Drives you crazy. Yeah, so that's why I think some of us have actually moved away from the laptop battery packs. It's just the what is it? How do you say that? Come on. So the ratio of bad to good, it's kind of low as compared to like all these other modem batteries, right? I actually order the worst batteries that Tom has. I bought 2 boxes of those Sanyo cells, and I actually want to do my test. I want to test this with those. I took 2 boxes, 200 cells. I'm gonna take them apart, test them or whatever, and then pop them in here. Maybe not test them, just pop it in here, see what happens, right? I want to do that. Those are like the cheapest ones you can get. I think they're like, you're paying like 60 cents or something, 65 cents per cell. I think I did the math to that, and so I want to do that, you know, that experiment to see how that is. And I think that's still even better, I think, than the laptop. You know, depends, right? It's like, depends on your source. There's some sources of laptop batteries that you just get lucky and you get a lot of them. But I think, you know, generally speaking, yeah, you have to go through a lot of them to find good cells. So the stream is fixed. That's weird. I don't know what I did. Maybe it's nothing I did. Maybe it's the, let's see, what does the speed say over here? I got join my network. Yeah, I'm gonna run this test and then it's gonna throw it all off. Watch. So let me see here. Is not the side. This is fixed. Has anybody played with supplying a switch power supply with 110 volts DC or higher? Has anybody played with supplying? Oh, so like an AC switching supply with 10. Well, yeah, I wonder what would happen. No, I mean, I don't. What would happen? I guess if it's got a rectifier at the beginning of it, it would just not see a difference. You just have to kind of make sure it's the same voltage after the rectifier, right? Because usually there's a drop, a voltage drop, I think, after rectifiers. I have an idea for a water-powered turbine, 163% efficient. 163. Wow, that's over Unity Island. Man, if you got that, let me know. We'll be rich. How much do you think EV West would charge to convert a 250 Tacoma Camry to electric? Probably more than you're willing to pay, because that is a non-cool car according to them, and they probably won't do it. By the way, they're backed up, like I heard, like years now, and they're only gonna do cool cars, or cars that they think they're cool, because there's just, you know, they're not into this mass production. They're doing it for the fun. They're not into, you know. So I mean, yeah, if they don't like the car, it's gonna be more expensive than if he likes the car. So I'm going to stick with the laptop cells because I get them for free. Well, there's no better offer than free. I've heard the rectifier doesn't do anything. Yeah, I mean, and when you connect AC to it, it does. It rectifies, right? But if it's already rectified, signal, it's already DC. So I've been running about $1.60 per cell, shooting for the ones that are newer with the goal of 15-year life. Yeah, just build a bigger battery, and then you should be able to do it. Too bad things Are all pouch cells not? I'm going to make more difficult since the size isn't the same for each one. Oh. Thomas Wrecking, thank you for the $2. What's an acceptable amount? Wait, this guy's just totally just opened the door. What's acceptable amount of internal resistance? I don't know. I think less. I think some people say it's like less than 100 milliohms, then you're good. If it's above that, then then it's not as good because it'll create, unless, and it really depends on how you're going to use the cell. If you're going to try to push a bunch of amperage more than like 2C off of a cell, yeah, you definitely don't want more than 100 milliamp. This one's, for example, we're coming in at, right when the guy sold them to me, said that they had incredibly low internal resistance of 8 milliohms, but once I tested them, well, at least with these crappy little chargers, right? They were coming in at like around 30 milliamp hours. 30 milliohms, not milliamp hours. So that'll give you an idea. If you're testing with those little cheapy equipment, if you're getting like 30 milliohms, then they're about equivalent to this, this is a really good cell, like really low resistance, high power output cell. So let's see. Oh my god, I can't go up again. Come on. Oh, there we go. Is 2200 milliamp hour battery, laptop batteries okay for 48 volt packs? There's a voltage drop after, yeah. I mean, 2200 is just the capacity, so it'll just, it has nothing to do with the voltage. The voltage is the same. That's just capacity. That's how long they can put out a set amount of load. The ones with the higher milliamp hours, they'll do it for longer because they can hold more energy. Learn a lot from your channel. And from the comments, it looks like others have too. Thank you, Oliver. Most of my cells run from 80-ish to 160-ish on Opus. BTC 3100 quick test. 80, okay, so yeah, I wonder, I have a box. Do I have a box? Let me see. See, guys. Oh yeah, perfect. Perfect. So I took this box and they were tested. I bought these 2600 milliamp hour tested cells from Tom, but then I put them through my chargers and then I tested them. Let's see, just random. 112 million. Hey, no barking. 72. Hey, what did I say? No barking. 100. 130. 128. There we go. 126. Let's do 10 cells here and then we can do the thing. 98. Okay, so yeah, there comes, probably if we do the average, it's probably about 100. 88. Let's see here. Another one. Oh, 216. Look at that one. This one's high. I might retest that one whenever I make my modules. These are gonna probably end up in my bus. 104. Okay, yeah. So I bet you so the average is probably about 100. At least on these cells, Hey, I'm barking, man. Come on. Be crazy. Okay, let's see. What else do you guys have? What would be the lowest milliamp hour batteries you would use on a wall? Well, that's depends on the cells, right? So if they were like 3400 milliamp hours and they're 1500 milliamps, that I'd say that's way too degraded and you probably won't be able to get things, right? But these are 1500 milliamp hours. That's what they are new. So you would totally use 1500 milliamp. So you can. It's going to be like it's going to be a percentage of the original capacity. That's what you should look. And at 70% of the original capacity, they are considered dead. Now, I think that's a little conservative. I think they still have life after 70%, right? You can probably go like 60%, like, I don't know, maybe 50%. I don't know, 50%. I haven't really done too much tests. There are probably other guys that have running, like Powerwalls running right now, that started with like close to like 70 or 80 or something like that. And could have better input as to where the batteries start falling off, right? Like where it's just too many problems for them to be useful or whatever. Hey, what are you guys doing? What are you guys barking at? My 4 dogs' ears are up to your dog bark. Okay. Do you have a test internal resistance for my truck light? I test the milliamp hours, or does it not really matter? The truck light? I don't understand that. Cells at 2166 milliamp hour per cell. 60 in parallel equal 130 amp hours. Who won the batteries this week? Oh, okay. So before I go, yeah, I've been here like 2 hours already, right? My voice is going, so and I'm kind of getting hungry. I'm gonna go eat. But before I go, let me see. Can I do this? Can I give something away? Oh, look at that. Okay, guys. I got these shirts, right? This week. I ordered a bunch of them, designed them, finally got them. I have one of these, but they haven't arrived yet. And so I have a bunch of them. I just got different colors and stuff. If you want one of these shirts, and if you wear, I ordered them all medium because I'm medium, and I basically wanted to see which ones were the ones that I would like, so that I could know like to order, you know, the ones that I like, and which colors, because there's some funky colors, and in the picture they look different than the other one, right? So look, if you are a medium and you want one of these shirts, comment. What should you comment? Comment anything. Me, shirt. Oh, comment the word shirt right now. And then like once we have, I don't know, like a good of them, then I'll just like randomly pick a thing, and then I'll, you know, you can send me your address, and then I can send you one. Let's see. Here we go. Here we go. Medium. It's a medium because I only order medium. So if you want this shirt, I'll comment T-shirt. I am triple XL. Introduce your dad in the background. I'm a 2X, so I guess I'm out. We'll do it. I'll set it up next time so that I'm able to give them. So like it doesn't matter what size, you know what I mean? Like we'll order it and then we'll have it shipped from the actual place that shipped it, because that's much easier than me having to look for a box and the label and stuff. But because I have some right now, and I'm live, and there's 164 views. Someone right here, I'm pretty sure I can find someone that wants a T-shirt that can wear a medium Samba. The E-Samba project. It's my bus. My brother's a jerk. He was like, that doesn't look like your bus. It's got the wrong bumpers. It's got the thing here. Is that like, come on. Like, this is not a picture. This is like a little drawing, jerk. All right, let's see here. I'm gonna pick. Okay, so there we go. Random. Okay, there's not one there. Okay. Shirt for me. There we go. And Mo. There you go. Can I do the thing? Go to channel. Put user in timeout. Hide this user channel. Add as moderator. Remove. Report. No, let's go to this channel. We're going to go to your channel and check it out. And Mo. 1 subscriber. Favorites. DIY Solar Tracker. Boom. This guy's a DIY guy. He deserves this shirt. Email me or... Yeah, email me or type... Well, you don't type your address there because then everyone's going to see it. Email me, jehu@jack35. You know, that you want the shirt. I'll put it in a little bag. In fact, here it is. Look. The one that came in. I'll put it in this envelope and I'll ship it to you. Alright, guys. And with that, I say we had a pretty successful little live Q&A after 3 months hiatus from YouTube, from the YouTube overlords. I'm back, and we had we had like over 200 people at sometimes. I'll look at the analytics. Oh, let me see. What's the analytics here? So the thing here, analytics. Woo! So concurrent 169, already 1100 playbacks. What? There's one. I think once it cancels out, it tells you like it gives you more info, like what was the top thing. Yeah. Look at that. Over 200, almost 250. I think I had like over 250 at one point. The blue one. And it even shows you whatever. Yeah, most of you guys are streaming on 480p. A lot of you guys 240, 360. Yeah, sorry for that. This connection wasn't that great today. But anyways, thank you very much. Remember, I have the Facebook group. If you guys are on Facebook and you guys want to share your project, it's like non-stop over there. It's just project after project. People are posting like all the work that they're doing over there. If you want some inspiration, if you want to know what people are doing, if you want to get some ideas, go to the Facebook group. By the way, to join that, I have where is it? Is it here? The door. Yeah. Click on the little thing there, and there's like a drop down. You can go there. What else do I have? Do I know? Let's see. Yeah, there's the links for the batteries. If you're building a battery thing, you could just go in there and then find the ones that you can get, and some are tested already. Some, if you're in Europe, we finally found a guy in Europe that has batteries. So if you're in Europe and you've been looking for batteries and you haven't been able to get them, there is a link in that first little drop down card. That's called a card, and so now you can buy batteries, and they're a good source. They're tested. So they're ready to go in the box. You should be able to just get them and then pop them in our little PCB thing here. And you should be able to make batteries really quick. So, yeah, make sure you check those out. Thank you for everyone that donated, the super chat thing. Thank you for all the patrons. If you're watching this and you're a patron, thank you very much. Oh, these guys. We'll see you guys in the next one. Have a good rest of your weekend, and we'll see you this week. We should have some good videos. I'm doing some projects. I might tackle the big Powerwall that will power my AC using the cheap Amazon inverters, grid tie inverters. I'm gonna try to do 6,000 watts using those and somehow cool them and somehow sustain like at least 20 minutes of peak, like total peak. So that should be pretty cool. There's a lot of, I think it's kind of adventurous. I might actually burn stuff, might risk it. They might not last. But that's the whole test, right? So I do it so you guys don't have to. All right, guys. We'll see you guys in the next video. Thank you for watching. Yeah, bye. So I'd have to do this. So you want to build a DIY Powerwall. I'll show you how to do one. Using these as batteries and these as your inverter, you can build a small DIY Powerwall. Let's get going. So how much does this Powerwall cost? Let's do a rundown on the prices of all the components. First, we have the solar charge controller available for $38.99, the bidirectional meter at $29.99, non-interruptible power supply available for $30. The battery modules are $50 each. There's 10 of them, so it's $500 in total. The 32-inch metal box is $59.22. A fuse holder is $682. The battery management system, the long ones are $14 each, and the main unit is like $200, so it comes down to a total of $342. All of these components come to a grand total of $1,008 US. You can find the links for all these parts on the description of this video. I want to thank you for watching. Stay tuned for future videos all having to do with DIY renewable energy. Let's talk about the EV West M3.
I'm Michael Breen with EV West, and 7 years ago we started our little electric car speed shop so we could help people make classic cars go faster. At the time we were looking around for venues, and there wasn't a lot available to electric cars, and we came across Pikes Peak, and they actually had a class. And we ended up building the car, purpose-built for Pikes Peak. We ran the race in 2012. We ended up setting a record for the fastest street-legal electric car to go up the hill.
Now, the car that Michael is talking about is the famous M3.
342 horsepower and 850.4 pound-feet of torque.
A few years later, I saw it Let's see if the improvements that we made to it are gonna make it go fast. Let's see if it'll burn rubber. Hold on. Some 100 kilometers south of the border, there exists a place. This is what's known as La Bufadora. It's a place where the water comes out. It's a blowhole. And let's sit around and watch the water come out here. I think I'm gonna get wet. So was La Bufadora all that it's cracked up to be? Or
Yes.
were you impressed?
I was splashed. Watch your step. Big splash.
Yeah, I was like 7 years old last time.
I'm allergic to birds.
All right, so I just arrived in Manhattan. My allergies are killing me. You see, oh my God, I feel like crap. But it's early. A few other family members are here this time around, so I'm gonna go meet them. They're somewhere already exploring the city, so I gotta go get them. All right, we made it to Grand Central Station. Back to Puerto Rico for the third time. We're gonna help some people get some power. Internal resistance and okay, so here's a whole pallet of these modem ones. Look at these guys.